Alright, this video I just wanted to go through basically what the scope is, what an ultrasonic scope is. So I'm going to do some moving around here. On the top here, this is a USM35. You're reading upside down. These are just the B and C hookups for our transducers. Okay? We always hook up at least to one of them. Right now it doesn't really make us much difference. But we've got just some general hookup stuff here where we can hook into computers or we can hook into VGA or whatever. Not a big deal. So we're just going to hook our B and C connector up here. Okay, that's gonna make us live. We've hooked a transducer up to it. And if you're just looking at this, you're seeing a 4-inch range, meaning that's how much material we can inspect. Okay, if I just slide this block over here. Oops, I hit you, sorry. Here's just an IIW block. Okay, IIW, see it's made by PH Tool. We appreciate that. We like those guys. So if we just look down on this block here, this thickness, okay, from the top of the block to the table is 4 inches. Okay, precision machine block. So that's a good thing. So we know that that's exactly 4 inches. Back off here so we can get the whole thing in focus. So 4 inches there, 1 inch thick. Okay, we've got a couple notches. You can see that notch there. And then we've got a step or a landing. This is actually upside down, but we're just using it like this for right now. Then we've got a piece of plexiglass or lucite right here, and that's going to help us with some sound dampening stuff. So 4-inch side, this guy's about 3.6, the little notch in there, and then we've got some other stuff going on. But anyways, if we back up to the scope here and roll into it a little bit, we don't see much going on. Okay, so if I just bring some signals up, try to bring some signals up. There we go. So now I've got a signal here that represents 4 inches. 25, 50, 75, 100 is where my signals are coming up. But I just want to go to a 1-inch signal. Okay, I mean a 1-inch range, meaning I want to see from the edge of the transducer right here. Okay, I want to see from the edge of the transducer right there out 1 inch in time in steel. Okay, and this is, let's roll this up to 233 to make that steel. Okay, that comes off your reference data sheet. And that's just going to be a good starting point. All this right here, all this jargon, this is the near field. So we're starting here at 0, and we actually have a near field that stretches out to about 0.8 inches in steel. So if we slap our transducer on here, which you can't see that I'm putting the transducer on there, so let me move you. So you see I'm just putting the transducer down on the block. Let it focus back in here. And if I lift the transducer up, you see that signal jump up and down. Okay? So that's all I'm doing right now. So I'm going to lower my gain and bring in my delay. I'm just going to use display delay right now. Display delay just moves the signals. Okay? Velocity tells us what we're inspecting. Range expands or compresses the screen. Delay moves everything all together. Okay, we've got a display delay and a probe delay. So on this scope we have those two. So if I push the pulsar button here, this is damping. Okay, damping tells us how much dampening power we're applying to the transducer. So if we dampen it lightly, we have a larger signal. If we dampen it more, high dampening, we have, okay, we've gotten rid of a lot of the near field, but we've also lost a lot of our signal. So going to leave that on low dampening. We can deal with this. There's other ways to deal with that. So if we go to low power and go high power, jumped our signal up again. Okay, but we also changed our near field here. So you see the difference between those two signals. Okay, and then if we turned on dual mode, we lose everything because we only have a single transducer. So let's turn that back off. Okay, next menu here, I hit the receiver button. We've got a frequency. This is reject control and fine gain. Okay, we're just adding fine gain. We're not really too concerned about that right now. Reject, that's going to help us eliminate some unwanted signals like you've seen in the theory stuff. Okay, and you see I'm losing some signals there. I've lost everything that's underneath 22%. So here we've got a reject that says blocked by a threshold of 23%. Which we have a gate on here that we can't see, and it won't let us block the gate out, basically. So if we roll that back to 0, you see we gain all that back. If we just change our frequency, okay, that's going to change how our signal looks. So we want to find the cleanest looking signal here. Okay, and that looks like about the cleanest. Alright, and then if we look at a rectification, a waveform, we see a full wave rectification, a positive half wave, a negative half wave, or an RF. Alright, and all that's telling us is radio frequency. This is a negative half wave, which is the negative side of this wave. If you just look at this RF, you see a bottom side of the wave here, and then we go to the negative half wave. What that has done is taken all that information and flipped it over, so now it's all going vertical, but we're only seeing the bottom side of that RF wave. Okay, there's the RF, there's the negative wave, there it is. Okay, so we switched that to a positive wave. Now we only see the positive side of that. So if we go back to the RF, we're seeing these two little spikes right there. There's our positive half wave, two little spikes right there. Okay? Go to a full wave, it puts it all together. I like to see the full wave. You could use the negative half wave in this case. It's a lot cleaner. I like the full wave, but for fun we'll use the negative half wave because it's prettier in this case. So let's go to a base menu and push this over to where that's at 100% again, or 1 inch. Okay, so that little 10 right there, we've got where the signal's breaking the baseline. Let me zoom you in a little bit. Okay, we're just looking right here where the signal breaks the baseline. And you can see that it's just a little bit in front of the 10. So we're going to take our delay, oops, we're jumping big here, we don't want to jump so big, and move it back. Okay, and now we're right on that 100%, which is good. So if we take this range, let me zoom you back up here so we can see. We run our range, get you set where you can see it, to 2 inches. We've got a signal at 50% and we've got a signal at 100%. So, this is a little bit about the scope and how they work.